Students, welcome to Physics for Everyone classes. This is your Satish sir. In this video, I'm dealing JEE 2020 Physics Solutions, which was held on September 2nd, Shift 2. And this video has been useful for JEE students as well as the NEET students for the rest of the examinations. If you follow this video, you might cover the questions along with some conceptual points. And if you're watching this channel for the first time, please subscribe and like the video. And then we have the first question on the board. Let us see. A rod is heated from 0 to 10 degrees Celsius. Its length is changed by 0.02 percentage. What percentage the mass density will change? And this question is asked from the chapter Thermal Expansion of Materials. And then we have got the four options. The option 1 is 0.02, option 2 0.04, 3 0.06, and fourth option is 0.08. What is the key idea for to solve this question? You see here it is asked the percentage change in the density of the rod. So firstly, I am writing the idea to get the percentage change in density. How to get? Key idea which is we need to find out delta rho by rho into 100%, nothing but the percentage change in density. We need to get this value. As you know, density is related with volume and the volume is related with length. So which means that in order to get the density, it will be depending on volume and the volume is depending on the length of the rod. Which means in that question, the information is given about the length of the rod. By using that, you can find the percentage change in the volume of the rod. With that, you will get the density of the percentage change of density of the rod. So, we know the basic formula for coefficient of linear expansion, which is given as alpha is equal to delta L by L into delta T. What is delta L? It is change in length. L is the initial length of the rod. Delta T is the change in temperature. You can see here the change in temperature is the final is 10, initial is 0. So there you got the change in temperature is equal to 10 degrees Celsius. And we don't know the information of initial length and the change in length. But here it is given the percentage change in the length of the rod is 0.02 percentage. Here we can write delta L by L is replaced with this value. You will get 0.02 divided by 100, which is 0.02 percentage into the change in temperature is 10 degrees Celsius. If you solve this one, you will get 2 into 10 to the power of, you see here, on the top it is 10 power minus 2. In the denominator, you will get 10 to the power of 3. If it goes up, 10 power minus 3. All together, you will get 2 into 10 power minus 5 per degree Celsius. So we got the coefficient of linear expansion of the rod is 2 into 10 power minus 5 degrees Celsius. With this, you will get the coefficient of volume expansion of the rod with the relation gamma is equal to 3 alpha. That is equal to 3 times of alpha is 2 into 10 power minus 5, which is equal to 3 to the 6. So 6 into 10 to the power of minus 5 per degrees Celsius. And once you know gamma value, you can find very easily the percentage change in volume of the rod, which is given by delta V by V into 100%, which is equal to, what you can write, gamma times of delta T, which is equal to gamma, which is 6 into 10 to the power of minus 5, delta T, the increase in temperature is 10. In the percentage you can take into 100%. So later you can find this one. You just find here delta V by V, which is equal to 6 into 10 to the power of minus 4. It doesn't have any unit because it is the fractional change in volume of the rod. And this volume is related with the density directly by taking the expression delta rho by rho, which is equal to negative of delta V by V. Both sides you multiply with 100% into 100% is equal to into 100%, that is equal to, how much you got delta V by V here? 6 into 10 power minus 4 into 100%, which is equal to 6 into 10 to the power of minus 2 percentage. Nothing but 0.06 percentage. Actually, it is you getting the answer in negative. Is it right? Because density is mass by volume. With this you can write delta rho by rho is equal to minus of delta V by V. You see here clearly the negative sign, because that the relation is inversely existed between density and volume where mass is the constant. So you got the answer. It is decreased by 0.06%. The answer is option. Here we have the second question, which is find the magnetic moment of the loop. Here we have the 4 options. You can see the options I, A, B, I cap plus J cap, which means that the answer is been asked in the form of vector form. The magnetic moment is a vector quantity. The key idea for this question is directly we can use the magnetic moment formula to find the result, which is M bar is equal to I into A bar, where I is the current which is passing through this coil and A is the area of cross section of the given coil. Simply by using this simple formula we can get the result for this question. Let us see. Now to understand this one, so we have got 2 planes here. For example, if I open this book in this manner, you can see clearly this side, this is AB, one conductor. The second one is the BC, this part is the BC, and this part is CD. There you can see this one is DE and this one is EF, which means that here the 3 conductors are being used to form this plane. What are the conductors? AB, second one is BC, and third one is CD. This forms the first plane. And the second plane is D2E, E2F, and F2E. So these 3 conductors forms the second plane. These 2 planes are perpendicular to each other. Can you see? This plane is on XZ plane. This is on the XZ plane, this one. And this one is on the YZ plane. These 2 planes are perpendicular to each other. Now, Let us take first the plane which is A, B, C, D, A, which is on X, Z plane. So for this plane, we need to find the magnetic moment. Let us apply the formula directly. So M1 bar is equal to, how much current is passing through it? I. I is the current passing through each and every conductor there. So M1 bar is equal to current into area of cross section. So how much is the area? The dimensions are given here. C to D, the length is A, and B to C, the length is B. The area comes as A into B, length into breadth. So I into AB. This is only the magnitude. To assign the direction, because it is a vector quantity, we need to assign a direction. By applying again the right hand thumb rule, the curl of the fingers gives the direction for the current and thumb gives the direction for the magnetic moment. If you look this loop from the y-axis, you can see the current is moving in clockwise direction. For the clockwise direction current, the thumb is acting in the downward direction, which means opposite to y-axis. We can assign the unit vector along negative y-axis is minus j cap. So you can give the direction to M1 bar is minus j cap. So you got the result. The magnetic moment for the loop A, B, C, D, A, which is IAB into minus j cap, which means it is acting in the downward direction or opposite to the y-axis. And try to find now the magnetic moment for the second loop, which is D, E, F, A, D. And this one is on which plane? Yes, it is on the YZ plane. It is on YZ plane. And the magnetic moment is taken as M2 bar, which is equal to the same current is flowing I into the area of cross section is also same. This length comes as A and this length is B. The area is A into B. And for to give the direction, again apply the same rule. If you look from the x-axis, this current, the current in this loop is moving again in a clockwise direction, you can see. With respect to y-axis, the current passing through this loop is clockwise direction. If you see, if it is a clockwise direction with respect to x-axis, there you will get the thumb is acting along the negative x-axis. So what is unit vector along the negative x-axis, which is minus I cap. So assign minus I cap to the direction for the magnetic moment for the loop D, E, F, A, D. So take care, this I is the current, which is a scalar quantity. But this I cap is a unit vector. Don't be confused with these two I's. And to find the magnetic moment of the system, we need to add all the vectors together, which is given as M bar is equal to M1 bar plus M2 bar. That is equal to, take directly this expression there. In both the expressions, the thing common is I into AB, here also I into AB. So take outside I into AB common. And the left part is minus j cap. And here is the minus I cap. And you got the result which is IAB minus I cap minus j cap, which is the option 2. Third question from the lesson units and dimensions, which is a very easy question. Let us see. If area A, time period T and momentum P are assumed as fundamental quantities. Then find the dimensions of the energy. This concept is very familiar to all the students. We need to express the energy in terms of the given assumed fundamental quantities. What are the quantities? The one is area, second is the time, and third is the momentum. So write energy, which is equal to area, capital A to the power of A, some constant, and time period, which is capital T to the power of B, where B is a constant, and momentum, which is P to the power of C. So what we need to find here is the constant values A, B, C, and resubstitute here in this equation. You will get the answer energy in terms of area, time period, and momentum. So let us start the dimensions of all the physical quantities here. The first is energy. What is the dimensional formula? Yes, it is m L square T power minus 2. Dimensions of energy, which is equal to dimensions of area, nothing but L square. You write here L square whole power A. Time period itself is T, capital T whole to the power of B. And momentum, linear momentum, which is mass into velocity, it comes as m L T power minus 1 whole power C. Just by comparing the mass, length, and time terms on both the sides, you will get very easily the unknown values. How? On the right side, rearrange the individual terms, like only m term is here. Directly you can write m to the power of C. And now pick the m L terms, length, L to the power of here it is 2a, and here it is L to the power of C. So you can write as the bases are common, you can add the indices. So 2a plus C. Similarly, time to the power of here it is B whole to the power of B, and here is minus C. So it comes as to the power of B minus C. On the left side, we have got m power 1 L square T power minus 2. Now comparing the coefficients, the powers of mass, length, and time on both the sides, you will get directly C is equal to 1 by comparing. So I am writing here C is equal to 1. And L to the power of 2a plus C is equal to L square, which means 2a plus C is equal to 2. And the powers of time is B minus C is equal to minus 2. You see here, C you got 1. So C, where it is momentum to the power of C, which means P should have a power 1. Here it is 2, here it is 2. So we can eliminate options 2 and 4. But in the options 1 and 2 we have got P power 1. So we need to find the one more coefficient here. So for that we can use here. So B is equal to minus 2 plus C, that is equal to minus 2. You got C as 1, so it is plus 1, that is equal to minus 1. So you got the B value how much? Minus 1, which means T to the power of minus 1 where it is 0. Here T power minus 2, here T power minus 1. Yes, you got the option 3 before you finding the value A. So do you want to find, you can take this expression, but not necessary because it is already been eliminated the 3 options. You got the answer for this question is option C, option number 3. But to find A, you can use this equation. So 2A is equal to 2 minus C, that is equal to 2 minus C how much? 1, that is equal to 1. And A is equal to 1 by 2, which means area to the power of 1 by 2. You see here, area to the power of 1 by 2, t power minus 1, t power 1. So for this question, option is 3 is the right answer. You see how easy is the question. The only one thing is that, you see, how much easy question is not the matter. How we are dealing the question always matters. Always we feel cool in the examination, relax, then all the things get in your mind at the right time. So take care.